Am I on? Okay. Good morning, everyone. Just some quick reminders. Of course, I'll mention the survey. We actually have gotten a record number of responses. We gave out an iPad mini yesterday. We'll give out one today. As well, I'd like to thank Terramark for the social last night. Those of you who attended, I heard great things. And I'd like to invite Lee Howard up to talk about something near and dear to my heart, which is his game theory for IPv4-IPv6 transition. Thanks.
Good morning. It is very morning, isn't it? I hope everybody's with me because this is going to be a little bit of a bumpy ride. I'm going to start with answering Dave's question from yesterday afternoon. He said, why do you need IPv6 only? If I've got a service where 99% of the bits that I'm delivering are delivered over IPv6 and 1% isn't that good enough? All the bits are coming over v6. And my answer is, I've spent the last year doing presentations about how expensive v4 is going to get. And so as long as a customer requires IPv4, the expense is already made. An ISP has already incurred the expense to provide IPv4. So not until you get to v6 only are you able to drive that cost out of the cost of doing business. And I'm going to get into that in a little bit more detail and show why that is. But I'm going to start with this description of this vicious cycle. You can tell it's a vicious cycle because it has sharp, pointy teeth. We have a problem where content and consumer electronics only support IPv4, and therefore ISPs have to keep supporting IPv4 because they have to provide access to that content and to those consumer electronics. They keep supporting IPv4, and the consumer electronics and the content only need IPv4, so they keep only supporting IPv4. So the ISPs have to keep providing IPv4, and it keeps going. And so I say to you, if you are an ISP and you're deploying CGN, you are contributing to the perpetuation of this vicious cycle. Because as long as you are incurring costs and spending money to keep doing IPv4, there's no reason for anybody else to support IPv6. So how do we break this cycle? There are two ways, essentially two ways. You can either break the top cycle or the bottom cycle. Content and consumer electronics can decide they are going to support IPv4. Thank you very much to Netflix and the content that is supporting v6. So content and consumer electronics can support v6, and then ISPs can start doing v6 only, or ISPs can stop supporting IPv4. That will provide a very strong incentive for content and consumer electronics to support IPv6. That's a pretty bold avenue to go, so let's talk about whether that's even conceivable. It could happen. I call this presentation a game theory of IPv4-IPv6 transition, right? So there's a game going on here. The name of the game is, when do I add IPv6? Everybody has their own strategy to this game. Everybody has their own set of assumptions, their own starting positions. But the object of the game is to maximize profit and minimize cost. Probably most companies are in that kind of business where they're playing that kind of game. You're going to maximize profit, minimize cost. For ISPs, I've kind of already said, CGN costs money. Go back to Nanog 56, and I did the TCO of CGN. CGN costs more money than you think it does because of the risks involved. Buying addresses costs money. Addresses currently trade at, we've seen lots of numbers from $10 to $12 per address in the market. That's before the RIRs even run out. That's before all the RIRs run out. I've heard numbers as high as 16, as low as much less than 10. So we don't know exactly what those numbers are, but everybody would agree that the price is likely to increase over time. So the cost is to support v4 is going to continue climbing. Now for content providers, the way for them to minimize cost is to delay supporting IPv6 for as long as possible until they start losing eyeballs. I'm going to stop and interrupt that statement for a second to say, except where people are following Tori Anderson's v6 only data center model. If you haven't seen that presentation, highly recommended. He presented it at RIPE 66. The IPv6 only data center can simplify an awful lot of things. Or CDNs. CDNs and cloud services are often major consumers of IPv4 right now. That's where a lot of the growth is. So those may be places where if you are a CDN or a cloud service, you may need to start doing a lot of IPv6 instead of IPv4 because you're running low on v4 addresses and your cost of business is getting higher. But for the most part, for your standard website kind of content, the way to minimize cost is to wait as long as possible. Same with consumer electronics. Why spend any money that you can why spend any money now that you can spend it next year, right? If you can delay, then delay as long as possible. But again, until you start to lose sales. And so here is sort of this odd kind of race that we have where you want to win this race by as little as possible. So you need to figure out, if you're a content provider or a consumer electronics manufacturer, you need to figure out when ISPs will offer v6 only so that you can offer v6 just before then, like the day before, ideally, right? You want to delay as long as possible just before you start losing business. It's sort of a fuel consumption kind of race. You want to stretch out your resources as long as possible. All right, so how do you figure that out? Well, here's a decision tree, and this is sort of standard game theory kind of perspective. So if ISPs say, we're going to have IPv6 only services at some point in the future, you as a content provider or you as a consumer electronics manufacturer have essentially two possible responses. You can either support IPv6 or not support IPv6. Those are pretty simple, straightforward choices, in response to which ISPs then can then either do IPv6 only for some customers, they can do CGN for some customers, they can buy addresses for some customers, they can do any mix of all three of those. And it turns out their options this is a turn-based game, their options turn out to be the same regardless of whether you do v6 or don't do v6. Now, how do you decide which one to do? What you do is you say, okay, for all 6 permutations there, you do v6, you don't do v6, and all the ISP options, you figure out what does that cost me and what does that cost the ISP. Now you know that the ISP is going to do the thing that is cheapest and most profitable for them. So then you figure out whether you do v6, what's cheapest for them, whether you don't do v6, what's cheapest for them. You figure out what's cheapest for you and work your way back and say, so this is the behavior that I want to do in order to get the ISP to do that behavior, and it's just like a chess game. You can predict what your opponent's going to do, and so you push them into the position of making the move that you want them to take. That's really kind of confusing, but that's the simplest version of game theory that I've been able to figure out how to summarize. So I'm going to try and simplify that a little bit further and make it very practical. How do we figure out all of that? Here's the game we're going to play. ISPs will offer an IPv6 only service when the cost of IPv4 is greater than the risk of not doing IPv4. In other words, here's the premise. When it's riskier to do IPv4, it's costlier to do IPv4 than it is risky to have IPv6 only, then the cost outweighs the risk, and that's when you start to see IPv6 only. So how do we figure that out? Well, so we need to calculate what are the costs of doing IPv4 and what are the risks of supporting IPv6 only. So I'm going to spend most of the rest of this presentation trying to put together some assumptions here and plug them into a spreadsheet. I'll give you the URL so you can download it and do your own numbers. So to figure out what IPv4 costs, you need to know the price of addresses, you need to know the cost of whatever your transition technology might be, and the cost of running dual stacks. You can compare all of those things. By the way, at Nanog 57, the last one, I talked about the costs of the total cost of the transition, but I didn't come up with actual dollar amounts. I refined that a little bit, and in INET Denver, I came up with a cost of running dual stack is about $4 per user for an ISP, about $4 per user more than running single stack. So that's the cost you're trying to drive back out. That's $4 per user per year, more expensive to run dual stack than single stack. And then the risks are, what if there's no content, or what if there is insufficient content? How do you quantify that? And what if the devices lack v6 support? That's where we're going. You with me so far? I know, it's really early in the morning, and I'm sort of throwing some pretty abstract concepts. So I'm going to try to again, keep reducing this down to the more and more practical as far as I can go. So let's start with a chart that you've kind of seen before. This is total RIR allocations over time. You've probably seen this one before in an ARIN or your favorite RIR report where the NRO statistics come up and they show a bar chart of all 5 RIRs, how much address space, how many /8 equivalents they've allocated year by year. I've just taken those 5 bars and stacked them and then made that a line chart so that I could then show what the demand for IPv4 has been over time. And you can see here, I did a couple of curves to see what the best fit was to extrapolate, and it turned out to be a very linear curve. So it's a linear extrapolation, and in 2010, it was about 15/8 equivalents. In 2011, it was about 14/8 equivalents, but a linear growth over time. Now, I stopped in 2011 because in 2012, RIPE and APNIC weren't allocating any more IPv4 addresses. Well, it stands to reason that when 2 of the 5 RIRs aren't allocating IPv4 addresses, fewer IPv4 addresses are being allocated. Right? So that's not really a valid data set to include in this extrapolation. The demand, I think, is still there. It's just not showing up in the RIR allocations. If you really want to know, there's a little X at about the 5.5, 6/8 equivalents. That's what was actually allocated by the NRO members in 2012. So I took this, and then I flipped it to say, all right, how can we extrapolate what demand's going to look like over time? This is, how can we predict the price of addresses? This is a really thorny thing to do. This is really risky, and I need to warn you that I'm not very good at predicting the future. So I did a study of route views, and I said, how many addresses have been allocated but don't show up in the BGP tables? And how many, and then I did some analysis of how much address space has been allocated but isn't fully utilized. And I think that there are about 1 billion IPv4 addresses available to a market. About 1 billion, sounds like a lot. It's not as much as it sounds like. So what I show here is take that 1 billion addresses, add in what the remaining RIRs have in terms of their free pool, and you get to about 1.15 million addresses, or sorry, 1.15 billion addresses. Now, if you take that linear demand that I showed on the previous slide, and you extrapolate it, and so if demand keeps growing at the rate it has been for the last 14 years, linear extrapolation, then the entire market would run out of addresses by the end of 2015. So if you think the address market is going to save us, we're already out of we've got 2 years before we're out of addresses. This is not a supply curve. This isn't even a demand curve. If this were a real curve, then there would be prices along the bottom, and you could see how demand would change over time based on price. That's not what this is. This is a simple extrapolation of if we kept consuming IPv4 addresses at the rate we have been. Now, if you say it's not going to keep growing at that rate, we've got V6, demand is going to be suppressed a little bit, it's going to stay flat rather than keep growing, that's the red line. We're still out of addresses by 2017. Only if you go to that last line, if you think the 6/8 equivalents assigned in 2012 is what's going to keep being, is the continuing demand, then that gets you out to something like 2027, right? That's probably not realistic, though. It's probably much sooner than all of that. Now, I've also gone in and drawn some black lines where the addresses available change. So above that top black line is you can still get addresses from an RIR. It may not be RIPE or APNIC, but you could theoretically somehow get addresses from an ARIN, LACNIC, or AFRINIC. Once the RIRs are completely out of address space, the only way to get addresses is to buy them. So I believe there would be a price inflection point there. Price for addresses will get more expensive at that point. Seems reasonable. I don't know exactly how much, but right around there, one would expect the prices will increase again. Now, this next tier of addresses, though, these are addresses that aren't currently routed on the internet. People aren't using these on the internet at all right now. So those are very easy to make available to a market. So they're not too terribly expensive compared to where we are now, maybe even starting at about the prices that we're seeing now. The next black line is addresses that are routed and are being used, but aren't necessarily being used efficiently. So this is where it starts to get really interesting. So in order to make that last set of addresses available, somebody has to go renumber take their address block, renumber all their hosts into a fraction of that address block, and make the rest of the address block available. It's more expensive. It's riskier. The cost of renumbering is probably $1 to $3 per host, are the estimates that I've heard. So the price is going to be a little bit higher for those addresses. So I expect another inflection point at about 500 million addresses. Why do I do all that? Okay. Oh, I guess there was one more chart that I wanted to show, and John Curran made mention of this yesterday. there's been increased demand at ARIN over the past few months, significantly increased compared to previous years. So I was talking to Tony Hain, and we said, let's take, instead of taking the last 10 years of history and trying to do the best fit curve, let's say that the last 3 months is more predictive of the next 3 months than the entire last 10 years. So by doing a heavier weighting of the past few months, your curve changes. So he's got a very high exponential polynomial that ends up saying something like, he's updated a couple times since I took this snapshot, but it's sometime in October of this year is when ARIN runs out. Now that's pretty bold, right? And he's overlaid here the red line is the APNIC run out, so you can see their curve changed dramatically at the last few months. Now, what's really interesting to me about this is when you look at Jeff Houston's run-out projections, he's projecting when ARIN hits their last /8. Now, ARIN doesn't have a last /8 policy. They go right to the end and keep allocating until they've got no more address space to allocate. This projection shows when ARIN would get down to its last /24, assuming all addresses get handed out equally. So this is a very frightening kind of number to me and shows potentially when that first inflection point might hit. So based on all of that, let's pick some numbers out of the air for what prices might look like over the next few years. Now remember, what I'm trying to do is I'm trying to figure out the cost of IPv4 so I can compare it to the risk of not doing IPv4 so I can figure out when it's more costly, when it's too expensive to provide IPv4 at all. So I'm going to pick some random numbers that, not random, I'm going to pick some numbers and say that next year addresses will be $16 each. Is that right? Probably not. I don't know what it's going to be. Your ability to predict the future is at least as good as mine. I've given you the data that I have. I've given you the analysis that I can. Make up your own numbers. I've picked some numbers that seem reasonable to me over time, and again, I think there are a couple of inflection points where the prices do jump up a little bit. I've also included in this table the cost of carrier-grade NAT based on the TCO of CGN that I did last year. But I'm not including the risk here because I'm going to come back and model the risk again separately. So the base cost of CGN is about $6 per user plus a fraction of the cost of an address, because you have to have an address to put on the outside of your CGN, and I picked 10 to 1 because it's nice round numbers. You can disagree with this. I hope you do, because these numbers are not based on any kind of fact. I'm predicting the future. If I were good at predicting future prices, I'd be retired based on stock market predictions, right? So I'm not a genius. This is just, I'm picking some numbers based on some reasonable, to me, sets of assumptions. You get to make your own assumptions. You get to plug in your own numbers and do your own analysis. I'm just trying to provide a way to be thinking about how to think about these things. All right, so there's the cost. Let's talk about the risk. Now it's how do you model risk and how do you quantify risk? How risky is it to do IPv6 only for a given internet subscriber? If the content that if whatever the consumers want to do doesn't work over v6, then they might cancel. That's your fundamental risk. Now that could be content like a website, or it could be an application. It could be a voice over IP application that doesn't support v6, for instance. That might be important. And there's some risk that if that application or that content doesn't work, there's some risk that your customer might cancel. That's expensive. That's, you're trying to maximize profit, minimize cost, and you're losing if you incur that risk. But not all content is equally important. So how do you figure out how important a given website or a given set of content is? The guys at Cisco, the Six Lab, did an interesting analysis where they said, well, we can sort of stack how important something is by the number of DNS queries we get. Not perfect, but it tracks actually fairly closely with the Alexa rankings for web popularity. So for any given quad A query, what's the probability that that site has IPv6? And they've come up with this nifty map, and here's the URL for it. They come up with this nifty map. And as of this morning, I think they said that something like 48% of quad A queries in the US were for content that did support v6. Now again, this isn't perfect because some websites have very low TTLs, and so you get a lot of DNS queries. And there are some websites that do generate an awful lot of DNS lookups, but aren't necessarily quite as important compared to some websites that are very important to a user. If you can't get to your bank website, as an example that's been brought up to me, if you can't get to your bank website, you're probably upset about that. Compared to if you can't get to ask.com, that's not quite as important to you maybe. So I said, all right, what if so how much does it take to get us to a higher level? And it turns out, the analysis that I asked the guys at Cisco, and we said, if we can get Amazon, Microsoft, eBay, Craigslist, LinkedIn, Twitter, and Disney, 7 companies, if those 7 companies would support V6 on their websites, then we have 63% of content measured this way. 63% of content is available over IPv6. That's not much. 7 companies isn't that many, and these are some companies that may well be motivated to make some changes. I encourage you, if you work for any of these companies, to not only support IPv6, but to say out loud that you're about to add IPv6 support, or at least say to me quietly that you're about to add IPv6 so I can stop shaming you in public. Or trolling like I did yesterday. Okay, where does that take us? Zoltar's crystal ball. Now, this is the spreadsheet. You can see the URL down there, www.asgard.org, ASGARD, /images/game_theory.xls. You can go to just the website and click documents and you'll find it. By the way, my personal website does not yet support IPv6 because my hosting provider does not yet support IPv6. They have lost my business, but I'm still in the process of moving the files to a different provider. I apologize, shame on me. So I'm willing to eat the dog food and I'm willing to, I'll suck it up when I've made the same mistake. All right, so the set of assumptions that I'm taking here. I missed a good joke. What did I?
Who are they? Say who are they?
Network Solutions. Network Solutions will not provide me IPv6 hosting and will not provide me a way to update a quad A for putting someplace else. So let's pick a representative ISP that adds 100,000 subscribers per year. Let's say their average revenue per user is 400 and the profit margin is 35%. That's an average of the top 4 residential US ISPs based on their annual reports. So here's how to read this. The ISPs have three tactics they can choose in this game. They can do IPv6 only, they can do CGN, they can buy IPv4 addresses. The cost per subscriber for doing IPv6 only is essentially nothing, right? Once you've gone dual stack, you can do V6 only without spending any money. Actually, I can argue that the cost of doing IPv6 only is negative $4. You save $4 because you're no longer having to support IPv4. However, that's not really true. You don't really drive that cost out until you're able to do that for substantially all of your customers. You're still doing all of the network support and updates and software and everything to support IPv4 until you're really pushing IPv6 only very broadly. Now, the percent at risk for doing IPv6 only, here we're starting to get a little fuzzy. So percent at risk for doing IPv6 only. If 63% of content is available over IPv6, then 37% of content is at risk. So 37% of the sites that your customers hit are potential risk sites that might cause them to cancel. Now, how likely is it that they are to cancel? Well, I told you the top 7 sites that if they support IPv6, then we're at 63%. The next one down is ask.com. I was speculating at breakfast, and I was trying to figure out that I was surprised that Ask was actually quite so high, and I realized it may well be because they auto-install the Ask toolbar. I haven't yet done the testing to find out what happens, since they don't support V6, what happens to that toolbar if you do V6 only? Does that improve your performance? I'm not sure. But your customers, in any case, are unlikely to cancel because they can't reach Ask, right? So how likely is it? I chose 25% that any given customer affected by this risk would cancel. CGN, this is from the TCO of CGN presentation last year, $10 per sub. Again, I'm picking a date in the future where we have certain assumptions. I'm not picking today. So let's say someday in the future we have addresses costing $40 per address. That means that CGN costs $6 plus 1/10 the cost of an address, because you have to have an address outside of your CGN. So $10 per sub for CGN. I said 13.6 or 13.7% of subscribers who are put behind CGN are at risk. Something breaks for them, and let's call it a 50% chance that they cancel because they're upset by that. And buying addresses, if the addresses cost $40 and you pass on 100% of the cost to the customer, then there's some risk that the increased cost to the customer that they cancel or they don't sign up in the first place. So let's call it a 10% risk, because $40 per year isn't all that much, but there's some risk. Now, you might decide that you don't want to pass on 100%. You might eat some of that, erode your margins, and only pass on 50% of the cost. Then your risk of the customer canceling is lower. On the other hand, you might want to preserve your margins and therefore pass on 135% of the cost, and so the risk of losing that customer goes up a little bit more. I don't know what the right formula is. I'm not in that business, but that's why I'm providing this spreadsheet so you can go in, plug in whatever numbers you like, and then see what kind of results come out. Here's the results page. This is all in the spreadsheet. By the way, if you are a content provider or a consumer electronics manufacturer, there are separate tabs in the spreadsheet that I'm not discussing today that let you do your own math for your side of the business too. So here's the triple mix. ISPs can choose any of three options. They can do IPv6 only CGN or buying IPv4. They can do a mix of those things. So in the spreadsheet, I have every permutation at 10% increments for each of those mixes. Then I list the base cost based on the assumptions in the previous slide. The base cost is the capital. How much did you actually spend in order to implement whatever set of solutions we have there? Then we have impact. Now impact is the risk times likelihood. How risky is this method, is this strategy you've chosen? How much, so that is, how likely is it that the customer is going to bump into something that's bad? And then how likely are they to cancel? And of course I've added cost in there because you always, you've already lost that money. That's built right into your total impact. So cost plus risk times likelihood. And then I have the worst case scenario, and that's just if the likelihood's 100%, right? So if the likelihood of a customer if all affected customers cancel, that's kind of your worst case scenario. So what I've ended up here with is you get to choose which set of criteria, which set of impact is most important to you. Is it how much capital you actually spend? Is it the overall impact? Or how much weight do you need to give to the worst case scenario? Now the numbers that I chose fairly carefully after playing with the spreadsheet for a little while so that I could figure out, okay, at $40 per address, with those 15 sites all supporting V6, doing 100% CGN, you come up with a base cost of $1 million, makes sense, $10 per customer for CGN times 100,000 customers, $1 million. Then the risk and likelihood, it was 14% risk and 50% likelihood, you come up with $3.8 million. That's what it costs at that set of assumptions to do 100% of your new customers behind CGN. Nifty. So then I took a couple of other lines there, and gee, at $40 per address, you start to see that IPv6 only has zero capital cost because you've already done dual stack, and actually most ISPs are not spending a whole lot in capital to deploy V6 in the first place. Zero capital cost and the lowest impact of all those options. So at that set of assumptions, it starts to make sense that even though not all content has migrated to V6, the most cost-effective thing for an ISP to do is to offer IPv6 only. I'm going to say that again. According to my set of assumptions, when the top 15 websites support IPv6 and the price for addresses on the market exceeds $40, then IPv6 only makes sense. So now all we have to do is figure out when is that set of conditions true. I don't know. I can't predict exactly when addresses will hit $40. I do know somebody who would be delighted to sell us /24 for $10,000. If anybody wants to go in on that, that would get the price up to $40. Doesn't seem like the right way to go. What I'd like to do is I'd like to say, everybody download the spreadsheet. Everybody plug in your own set of assumptions. Figure out what year you think those set of assumptions is true. And then let's all get back together and talk about what date can we choose. Can we choose a date together that we can all commonly work for to make V6 a viable alternative to V4, so we can commonly reduce all of our costs across the internet. So the remaining questions I have is it even possible? Can we work toward a common IPv6 only date? This is, I didn't come here just to entertain and provide some thought-provoking questions. I actually want to see if we can take this home and work on this, because I want to work on this together. And what do we need to do? How do we go about picking whatever that date is? What's the next step? I've talked about this with a few people who've said there are some interim steps that have to be taken. So the first one was, well, what happens when you turn off IPv4? What does IPv6 only look like? I presented the first couple of days of research on, testing on that yesterday. That's what that was for. The next step might be, well, let's find some V6 evangelists. Let's find some people in this room maybe who are really gung-ho about IPv6 and have them turn off IPv4 at home so they can see what it really looks like to live on IPv4 only. I would recommend, if it were me, I might have a separate segment for the rest of my family because they might get mad at me. They might not like the IPv6 only experience. But, okay, so if we get 3 people a dozen people, a couple dozen people running v6 only, suddenly there are a few people. We can go to content providers. Content providers can hear us say there are indeed actual IPv6 only users in the world. What does that look like to them? Do we need a prep day? Do we need to declare a date in 2014 to say content needs to be ready to be support v6 only by that date? Do we need to say we as a collective group maybe pick a date where we're all going to turn off v4 for ourselves and see how it looks, maybe just for a day, and report back to the rest of the community what our experience was like? And here's the one that kills me. This is the one that I keep coming back to. We all know, I don't find anybody except some vendors who believes that carrier grade NAT less than sucks, right? Everybody says, we're going to do carrier grade NAT, and once we do carrier grade NAT, the experience is going to be so bad that everybody else will start supporting IPv6. Well, if we know it's going to stink, do we have to do it? Can't we just skip that step, please? Some people have said, well, what we should do is we should slow down IPv4, or we should have, not provide enough capacity in our carrier grade NATs. Good luck with that. I don't know how to sell that one. So I'm very interested in people's answers, people's thoughts about this structure for how to think about how to get to v6 only, and answers to the questions that I have up here. Thank you very much. Any questions, comments, thoughts?
We're going to limit it to 3 questions.
Okay, I'll go quickly. Dave Meyer, nice talk, thank you. I was wondering, in your modeling, how much you've weighted, or if you've looked inside the exogenous factors that fit inside, like risk. Like, for example, I'll just give one for example. So you're talking about the price of IPv4 addresses going up. At what point does it become an asset? I mean, or if ever, and if so, how does that affect your model?
So I have not figured out whether IPv4 addresses should be considered capital or an operating expense. So I don't know how they get. I don't know how the accounting works.
I mean, there's a whole bunch of stuff like that. I was just wondering if inside something like risk, you've done any deeper work on that.
No, not really.
Okay.
Hi, I'm Masato from SoftBank. Can you go back to the slide about life of address market?
Was it this one? Or?
No. Yeah, this one.
Okay.
I'm afraid it's still, even though blue line is still optimistic, because the address consuming speed in laconic area and aphanic area is growing up, then 2014 laconic area may run out the address space. So people in that area will rush into the market. And actually, on 2010, laconic people still said, oh, still we have enough address space. But in last year, they changed their comment, oh, we are running out. So I'm afraid that similar thing will happen in aphanic area in near future. So that's the reason why I think still blue line is still optimistic.
That makes sense to me.
So I actually, Phil Rosenthal from IS Prime. I actually wanted to point out there is actually another way to look at it, that it is perhaps not even this bad. When you run to the point that you can't get an ARIN allocation and IPs start costing money, a lot of companies may start saying, like, my Comcast at home, if I do a scan on my /21 that I'm provisioned off of, maybe 10% of the hosts on any given time will actually even answer ARP. They're not there. So maybe the DHCP server could be configured to, instead of give the IP for a week, maybe only give it for 6 hours, something like that. And when we start approaching a run out, maybe we'll just start getting more efficient with the resources that already exist. There is a lot of cost to going to v6. I mean, as a web hoster, we see a lot of software that, while it quote unquote supports v6, it's not perfect. There are still bugs. So that's all.
I'm not sure how much more efficient tighter DHCP leases would be, but I agree that that's something that we're likely to see. Thanks.
Thanks.